So hello once again. My name is Piotr Pasich, and this presentation will be about my experience with the test automation in the backend projects based on the TypeScript, mostly on the TypeScript. And the story of this presentation started some time ago when I was talking with my friends. And we were just, complaining and moaning about our situation in the company because we were working in different companies. Who's working on what? Why is it so bad? Everybody was complaining about that. They not having any automated tests or pretty limited tests in their projects. And I said, hey, but we have like 100% of code coverage, and it's pretty good. I'm pretty happy about that. And we started comparing our experience with it, what went good and what went wrong in our professional career, because few years before we were working in the exact same company, in the same exact project, and we started thinking about that. Where is the difference? And I have found it really interesting because how it went, what we did good on or what we did bad during our projects, and why we achieved 100% of code coverage or more. I will explain that later, and why my everyday work looks like this. And to be honest, this presentation will be mostly about the process of thinking, introducing automated tests into your project or into your company. And my main goal is about to show you where you can fail or what can go wrong, and how to actually actively pursue everybody else to start writing automated tests properly inside your work. But first things first, 2 years ago, two years, like when we started the project that I'm going to talk about today, the very first project that we went really extreme with the test. We were invited by our customer to help with maintaining the application and developing the main environment for future development of the company, of their company. So we started as 3 devs with 36 microservices and 5% of code coverage inherited from the previous team, which were developing the same application for the last 2 years or something like that. And the client asked us to prepare the environment, the whole application, for the maintenance and development, future development by the in-house team. So after like a year and a half, we ended up with 45 devs, 180 microservices, and 300% of code coverage. 100% with the unit test, almost 100% with the integration test, functional test, and end-to-end test. So I counted that like 300%. And the main decision why we ended like this was to go actually extreme with what we're doing. Whatever we wanted to push to the repository needed to be in the highest possible quality from our side. And I have to admit, from time to time, it was funny. I was very proud of our work, and it was really cool to have it. And from time to time, as you will see, we did some mistakes, or we inherited some mistakes, which we try to avoid in the future, but you know how it is. So during our very first iteration, we started thinking where to start. What's the very first step in the journey to 100% of code coverage? And this is really simple, because you need to know where you actually stand and what you actually have in your code. So because we inherited the application with the Jest framework for the test, we checked our code coverage for all the tests, and at the time there were only the unit tests. So we hit it 5% in lines, functions, branches, and statements, which is not so bad as you may think, because for the last couple of months at the X team where I work right now, I'm helping with the vetting process, and usually I ask the question about the average code coverage, percent code coverage that the candidates have in their projects. And you will be surprised how many times I need to explain what the code coverage is, or what do I actually want to hear. When the candidate says it's 30, 80%, it's okay. It depends really on the environment that you're working in, how do you work with the client, with the development team, or how do you, or how long is the project. But usually when you ask a question, what's the difference between the unit test and integration test, it's okay to explain, but nobody actually have the integration test, only one or two people that I try to hire. So we started at this point where we had a 5-person, and we went extreme. So a little bit of math here. 26 line in a single service. This is just an example service which was more or less in the middle of our repository lines. So 5% of 26,000 lines is about 1,313 lines covered with the tests, right? But if we go extreme, and after 6 months, we added to this particular service 30,000 lines and removed 5,000 because of some development and refactoring, we ended up with 24,000 lines, 25 almost, which were fully covered with the tests, so 100%. So if you take these numbers, sum it, you will end up with almost half of that covered with the test. After 6 months, we've actually doing nothing with the inherited code. 52% of new code, of the code that were there, 100% of the code we produced was covered with tests, and that helped us with covering the bigger part of the project with the automated tests. We were pretty sure that it's good, but actually it was even better, because whenever you open a controller, a repository, a service, or something like that, and try to fix a bug, it's a one-liner usually. But to cover this bug with a simple test, like a unit test or integration test, you need to actually cover all the other lines. So it's not only the 52% that we actually developed, but also everything else that we touched and was around the code that we touched during the last 6 months. So 91% of our code was covered, just because we made the very small decision at the very beginning that we are going extreme, and whatever we push to the repository is covered with the test in 100%. And boom, that's it, right? Actually, no. The second iteration, where we focused on the actual maintenance and the quality of our tests, and we have found that we have some struggles with our confidence, because we had 100% of code coverage. We were too confident in the code. Whenever you reviewed the pull request and it was fully covered, we were pretty sure everything is working, so there's no need. If the architecture is right, if the design is right, and if everything looks correctly in the place, we were just pretty sure it will be working. But it wasn't the case. The case was that nobody actually was reviewing the code properly because of this level of the confidence into the test, which was pretty wrong, because the tests were too big, too wide, the files were too long. And whenever you started reviewing the pull request, you were seeing this kind of a message that the div is collapsed because it's just too long. You need to expand it. And there were like thousands of lines, dozens of files that you needed to review with the tests, and nobody was doing that. When you expanded those files, it looked even worse because it was looking like that. And just try to review that every single case, every single line of the code that you are going to maintain. So the only and the right and the best solution for that, to do the code review, is to go back to the time you were a junior software developer and every other software developer told you just one thing: just do it. Just focus on your job and just do it. We made a gentleman agreement between us, between the team. We will focus on that more. And here we are in the third iteration with cleaning, because after we started reading the tests, we lost our confidence in that. Even if we had 100% of the code coverage, the tests were pretty bad. So we started with the test descriptions, which we were not really happy about. It was not meaningful for us, and this is really funny because usually when you start programming, there are two the most hard things to maintain, to develop, or to create during the development, which is the cache invalidation. This is probably a quote from the Bob Martin. Cache invalidation and naming of variables. And this applies also for the test descriptions, because usually the developers doesn't care about that. Just show me what they did, what the function does. So usually our tests had pretty short, not meaningful, obfuscated description, or even copied from our other tests, because it was easy to just copy paste some part of the code inside the tests and cover another lines with it. So get the channel counter returns response. What for? The question was what for the channel counters should return, what kind of response, etc., etc. It just goes on and goes on with bad descriptions. I am lucky to have my wife, which is the business analyst and product owner. She usually works with the requirements and acceptance criteria. So she was she helped us with improvement for these descriptions. She told us that it would be really cool to go with the gherkin with the given when then. I will show that later, but not as it's described in the inside the documentation of the gherkin, because it's the wrong way of following that. Because it usually says when the user clicks some button, then some action happens. But the button may not change. The user may change. Who's the user? If that's a logged in user or not. So we started with defining our users. So in this particular project, we had the identity, which was our a logged in user, which was already authenticated and authorized. And the rest of the message was just what he was doing in our system. But there's still a place to improvement, right? Because after this little change, we had a bunch, 60, 70 different tests which were saying at the very beginning exact same thing. Identity should be, identity should be, identity should be, identity should be. It was pretty crazy. 60 things starting with the same way. And what the dry principle says: do not repeat yourself. So we improved that a little bit, and we started to split our tests into a couple of maybe not chunks, like areas. So in the description we described what actual the given statements. So as an identity, so I'm already authorized and authenticated, I try to retrieve a number of messages for specific channels. So this is our given and then statement, and then we have all the debts. It was not so cool yet, because every each statement or every test statement was dependent on the previous one. So we changed the before, into before each and every test that we run inside the inside our test suite was totally independent, and that was almost there. So there was some kind of an improvement, and then we came up with the idea: if 60 tests, like the validation tests, which are extremely important to cover, to be honest, this is the question that most of people are asking us. If we write automated tests for the validation, and the answer is yes, we do. I rewrote a couple of applications. We were refactoring a couple of times our current application that we are developing right now, and I have to admit the tests for the validation are one of the most important, because usually the business logic behind the validation is not only checking if the name or the first name or last name is a string, right? There's more. There's a validation if the user already exists, if you throw some error, if some kind of pairs of the fields are connected to each other or not. So probably this is a business logic, so you need to cover that. And after every refactoring, you need to be really sure that everything is in place, including the validation, because it would be so stupid to receive a message from your QA that everything is fine besides of the validation, right? So you need to cover that. Another great thing about the automated tests that I really like which really improves the code is the examples, because you can take like 60 different test cases and say, hey, for this particular functionality, and not one identity user can retrieve this kind of information messages from our API, but also the website identity or accredited identity. Three different kinds of the identities. So you have like a usual identity, which comes usually from the mobile app, which is totally different than the website identity, and the accredited identity is for the stock market. So, and all of them can access the same endpoint, but you wouldn't like to write 3 different tests. You would like to actually write a single test, but with 3 different values put as an argument, and that's it. You can achieve that with the examples. So another problem which we really face and really made our tests longer was the mocks and data samples. This is an example of one test that was inherited, and for some time we were writing the test in the same way, which was pretty wrong, because when you put some colors on that, the green are the mocks for the unit test, and the red color is the expected result, which is actually some sample data. And if you don't see the details there, that's totally fine, because probably when you do a code review under the pull request, probably you will not see that anyway. So you will just scroll down and not read all of those functions. So don't worry about that. We decided to split it and create some kind of samples and keep them in separated files or separated, just has pretty good snippets for that. Mocha with Chai has something else, I don't remember exactly, but it's also working fine, but not usually with all kinds of the objects. But we decided to put every samples into separated files, and that was funny because at the very beginning we called them mocks, but they are actually not mocks. It's like a sample object, and in the first like part of the test, you just mock in everything, then call the function, and then expect something, which is also taken from the external. The sample is taken from the external file. But we are not there yet, right? Because it doesn't do good. If you have 60 tests, right, like that, it will not work. It will be hard to maintain. And the main part of the main argument about the automated tests and having 1% of code coverage is also how to maintain the code, how to change something or refactor if you have so many tests to cover, to change while you're changing the code. But we'll be back in that later. So we split that into 3 parts with like actual criteria to meet the given part, when, and then. So basically, the given part can be separated into the before statement. And whenever you need to check if some function shows an error or some function returns something else, and your method throws an error because of the changed behavior, you can put it under the test or under the test before statement. But basically, for 95% of the tests, your mocks will be pretty much the same, because you will be testing the main behavior of the function. Depends on just on one different line, right? So if you put the get reply by comment mock under the test and just change the request, it will be the response. It will be more readable for the reader than having all the mocks in one place. And another part stayed in the same way. The second thing was to give an actual description which really meets the whatever happens inside the before statement. So it was even more readable for the reader, for the reviewer of the code review. And the next was to adjust our expectations about what's actually in the then state, because it's we decided to check one then statement, one thing inside the test. So whenever something fails, we actually do what fails inside a single test. So if you test something, you test really one single thing. And that was cool. And of course, my favorite, the examples, when you call the same code and just go with the examples. So whenever you have 60 other test cases that cover the same thing, but with different arguments, values, or whatever, you just call them an example. Sometimes the number of arguments for the examples is really wide, like 10 or 14. And at this point, we decided to just split it and into two different test cases, because it was just more readable. And the purpose of the tests for us were to not only maintain the quality, but also to maintain a documentation for the code. I'm not a huge fan of putting comments inside the code, because usually they're outdated after you put a dot at the end of the statement. So usually our documentation was inside the test, and that was pretty clever, I have to admit. And in order to separate all the tests that we had, we switched from the before to the before each to run the same mocks and reset all the mocks before every single test were executed. And some may say that it increased the execution time. Yes, but no, because our tests were running for just a couple of minutes, so the integration and the unit test for 3 or 4 minutes, something like that. With the full build, so unit tests were pretty fast, and after we switched to the before each, it added only a second or something like that. So it was not so bad, to be honest. And when we were doing the code review, we spotted a couple of mistakes that were inherited or which we have done inside the code. The very first was that when you do not test your code, you usually miss some point, some requirement, or just some else statement. This example that you can see on the screen is probably really simple. You can see that if the type is different, and probably the type should not be int type of the string, but of some kind of an random, you will not the function will not return a price but undefined, or probably will throw some kind of an error. And if you will think about more sophisticated example, you'll probably find something like that in your code. We have found like dozens of that kind of an example which were not covered with tests. So that made us thinking about how we actually test our code and how we create acceptance criteria for the tests there. Another example was something what we inherited from the code. Somebody was just putting the expected statement, the assertion, inside the mock function, which could be never executed properly. And that was pretty painful, because from time to time it happened that you change the code totally, like refactored a function or a method, and it was totally different, but the tests were still passing because actually nothing was checked there. The mock was not called, the function, the get type was not called, so probably the assertion was not checked at the end. And this is all about and we started to changing that, like refactor, because we wanted to be really sure our tests are working properly. So we started to refactoring that to a more meaningful way. So moving the expect function inside the actual test. And then we realized the function to be called doesn't really check what we need to check, because it means, yes, the function is called, but with which kind of a value. If you get the type and you have just a single value, it's okay, but if you need to map this value in some meaningful object, you will need to check if this object is actually what you need. So we made a rule with that, that whenever you need to check if the function was called, you need to check also with what arguments there. And the last step was to, maybe not the last, and the next step was to check how many times this function was called. And that was really important, because from time to time it happened that the function was called twice or 3 times, because it was in some kind of a for loop or for each or something like that, and we were not aware of that. And that was when you run an application with big data, with billions of records, it really is really important to catch this kind of bottlenecks. So the very last step was to add the reset mock at the very beginning of every function, so in the before each function, to make sure that our results from the don't go from the previous test. Because if you go from the one test to the second test and you check the same mocks, it might happen that the function was called in the previous mock, but in the previous test, but in the current test it should be called, but it's not, actually not, and the test is still passing. So that was pretty rough. And another example, another thing which we really wanted to add into our code was that which function should not be called. It's really important, because usually, let's get an example. When you register to a new group, you are already existing user, and you are registering to a new group inside some kind of an application. You might receive a notification, but on the other hand, you might disable the option to receive this kind of notification. So you have a pretty simple if statement. If you enable if this kind of notification is enabled for you, you will receive it, and if not, you will not. So probably you would like to know actually the function or the method which sends the notification is called or not. And we made another rule and another gentleman agreement about that. We always check all the functions that are called or not called inside our methods or functions. If you are thinking right now about that, it's too much because sometimes it's like 40, 60, or 15 different functions, then probably you need to rethink your architecture. The tests are really great point where you start thinking about your code architecture, because you need to actually use that as a third-party user, which takes a look totally from the different perspective of your code. If you need to mock something and it's really painful for you, then probably the code doesn't work, or the code design doesn't work for you. Another funny thing that we spotted inside the test was testing something in a for each or in a while or for loop, and whenever the get response didn't returned an empty array, then none of the assertions was called and the test was still passing. So the very first thing that you may think about was to add a number of assertions at the very end, and that's pretty fine because you know that the loop statement will execute for a couple of times, for exactly 3 times. But hey, why not to check a whole API response to be really sure what's inside, not only a single thing. And this is really helpful while testing the contracts on your website, because if it changes at some point, you will get the test will fail. Another funny thing was about putting the expect inside the catch. That's obviously will not execute when the code will not fail. So still, you can add the assertion at the end, or use something really useful, which is in every testing framework. Right now, just expect that the function rejects some function. And the question is why we face such a thing, or why we were developing this kind of anti-patterns in our test. There were a couple of reasons. One was that we never went so extreme with the tests before. We never thought about the tests so wisely before, and didn't do the proper code review in previous projects. Yes, of course, there were some tests with 80% of code coverage, and everybody was happy about it. But usually the tests are like a second part of the development. It goes with just before the pull request or something like that. At this particular point, we put the test as first. The other thing why it was happening was the thinking was some kind of blocked mind that were thinking that in the source files, you usually apply all the principles, like the keys, dry, solid principles, and other fancy code architectures. But in the test, it's like, it's just a test. It needs to pass, right? We decided to put every piece of our knowledge that we know about the right architecture and how we should code without repeating, keeping everything simple, single responsibility, etc., inside the test suite. So we were really focused on that. And then we ended up with something with the fourth iteration, which is integration tests. And this is usually the integration tests are usually underestimated, because most of the developers are writing just the unit tests. If I ask during our vetting process, our candidates, so what kind of tests do you do? They usually say, we do the unit tests, but no integration tests. Because why? Why should we? Everything is tested by the QS. Yes and no. So when we started, we created like a separate directory, and we needed to start with a definition of the integrated test, actually, because when you ask somebody what is integrated test, you will probably give a really abstract and straight answer about that. But when you ask what actually should test the integration test should test, that's obvious, because probably in the microservice environment, because probably it should test all integrations, but which one, with all our microservices or with all the services that we are, or third-party applications that we are connected with, maybe Salesforce, maybe some payment methods, something like that, maybe some boxes. So we made very first decision that inside the microservice, we actually are integrated with everything what we have in the configuration and what the microservice manages. So usually microservice manages a couple of things like the database connection, the SQS or SNS connection, something like that. And whenever we need to connect with the third-party microservice or application, API, or something like that, we just mock it. So the very first, and that was funny, the very first step with creating the integration test, where you had only, you had all the external services mocked and all the internal services on place, was to copy the actual stories that we wrote inside the unit test and check exactly the same things for the controllers, because we had all the unit tests for the controller services, repositories, domain, object, and other stuff. And here we need to just copy the controller tests or the HTTP requests test and change that a little bit, because the business logic was the descriptions of the business logic and the acceptance criteria were just there. So we have taken the same place, the same tests, and just removed all the mocks, because why not? And so we ended up with the code with no mocks, the same test, and only one or two services, third-party services, which needed to be called, required us to write mocks, and that's what it was. That was it. Sorry. So why we need code 100% of code coverage in units, integrations, and end-to-end tests, you may ask? Because it's not so simple. It's not the same code. We realized that after a moment or two, that even if you copy the same part of the code from the units to the integration test, you need to take different approach to that. So first of all, we started. You need to generate some data in the database. You at this point you have a couple of different approaches. You might load predefined like a whole database from the snapshot. You might generate your data, and after every test, just remove the data from database, which I actually prefer, because every test should be we should be able to run every test or every test suite separately. And this is what is actually different. The second thing which is different, you need to, instead of calling the function, you need to run a copy of your server while you're running the test, and call the API like you're calling it from the Postman or from the Swagger. And this way you will be able to check all your routing, all your validation, and all other stuff that is not actually checked in the unit test. And the next step, which is pretty cool in my opinion, is moving this whole part of coding into the Gherkin. Because you might say the same thing and ask your business to help you writing the requirements in the way that you can put inside your inside your code and just copy all the requirements. So usually when you need to log in as a user or log in as some kind of an identity or participant to the group, you need to create a new group for that, create a new post. You will have all the pieces in the one place. And for that, we use the Cucumber. And still, you can just prepare all the requirements on all the given states when and then, and copy them aside for different tests. But with integration tests, there's one thing that you cannot cover. There are a couple of things that you cannot cover, like you cannot easily, like in the unit tests with all the mocks, emulate some kind of a behavior, because usually when you integrate with the SQS and you get the message from the SQS, you probably get a JSONized object, and from the perspective of the integration tests, you will not be able to just push the message without the JSON into the queue, but you actually need to test that, or you will not cover the code. So some parts of the code might be ignored, and you need to be really aware of that, why you're ignoring that in the test and do not cover with tests. And we decided to put under this kind of lines or this kind of functions a meaningful comment. Why we are not testing it, where we are testing it in the units. We cannot emulate that in the integration test, and so that's it. So the fifth iteration was to manage the data fixtures, because usually when you create an integration test, first thing you need to do is loading some kind of a data. Yeah, and usually when you start reviewing data fixtures for integration tests or the integration test itself, it looks like this. And this is like a mess, because usually the first like 1,000 lines are just predefined groups, identities, users, posts, comments, or something like that. We moved all of that to separated files, and we created just a base model with the samples, and whenever we needed to change something, we copied the same object with a new status or with a new with different fields. So that helped us with generating the data correctly. But that's only one approach. In this particular approach, you have full management of your data and what's actually inside your database, or what are you testing right now. Another approach is to use the fixture generators, which is pretty cool, because you can you don't need to write the samples, you need to just define how the samples are looking like. And the second fancy thing about that is that you don't need to define 1,000 users that you need to test. You need to just create an array with 1,000 users, which will be fulfilled with some kind of a data, and that's it. And you will be able to check if your function performs well, because in the jest you can define how the timeout for every test and for every function, which can be wisely used. For example, if you have a function, and in the big data applications it's really useful, because if you fulfill your database with 1 million records, so you can define that you expect to have filtered users or filtered posts with retrieved within a second or two, something like that. And whenever you create a new filter or new statement or a new condition, and this time will be exceeded because of that, you'll get a notification, because all the tests will fail, and that's pretty cool. Of course, this is not like performance tests on the product on the dev environment where you just hit and check how many comments or how many posts can you handle. But when you are pretty sure that on the dev environment you handle a million posts within some kind of within some time, and this time will be put here, you will be able to just manage that. And the very last iteration was implementing the static analyzers, like the lint, linter, standard X, depends on in which programming language or are you working with, if that's just S, JavaScript or TypeScript, just use it. You will not face any comments like there's a missing semicolon and at the end of the line missing new entry, a new line somewhere or something like that. Somebody will just take care of that, and in my opinion, this is some kind of an automated test that you can cover. And of course, the logins. The logs are pretty important because you are always able to check what's going on. And in the modern applications, you probably do not have an enter to log into the production version because you shouldn't have. So the logs are the only are the only thing where you can check what actually happened at the production environment. So the checklist for you while you are developing new tests is to always start with the API smoke and sanity testing. While you start covering your code with the tests, cover all requirements and acceptance criteria. Check if the return data is correct. Check once again with the bigger set of data. This is the fixtures that you generate automatically. Ensure that all API responses are tracked and saved. Make sure to perform negative testing. This is all about the validation, all the thrown errors, etc. Enforce service level agreement, SLAs during testing. Remove dependencies while possible for unit and integration tests. Eliminate as many fixed data sources as possible, and it's all about data management. And this is a checklist which we always check during the development and the code review that we do for all the tests. And that was it. Thank you very much. And back to the studio.